Chapter 8, Lesson 10, Systems of Equations. Okay, first thing we're going to look at is what is a system of equations? Systems of equations are, it's a collection of two or more equations with the same set of variables. Okay, when I'm looking for the solutions of the system of equations, I am looking for ordered pairs that work in all equations. The systems we're going to look at today are only going to have two equations, so we need to find the ordered pairs that work in both of them. Okay, and how to get a solution. The first method that we're going to look at is graph the equations on a coordinate plane. All right, before we look at this example, I need to make a little correction. I need you on your paper to change y equals x to be y equals x plus 2. All right, so change that before you start graphing this example. All right, so let's graph this. So y equals x plus 2, I'm going to go up to positive 2, and it has a slope of 1. All right, so I'm going to graph some points on both sides. And there's my line. And then I'm going to do y equals negative 2x minus 4. So I'm going to go down to negative 4. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I found this point right here where they touch each other. Those lines cross, and that ordered pair is negative 2, 0, and that is my solution. Now, sometimes two lines we find when we graph them, they are parallel, and that means that the system has no solution. So let's look at an example. All right, negative x plus 1. So I'm going to go down to, or up to 1, and I'm going to plot a point, and negative x, so I have a negative 1 slope. And I can go the other way, and I draw that line. I want to use a ruler to go as straight as I can so that I get those exact points. And the next one, negative x minus 3, so I go down to negative 3 on the y-axis. And again, a slope of negative 1. And I can see that since they both have a slope of negative 1, my lines are parallel. So I write no solution. All right, sometimes though the lines are the same. They're right on top of each other. And that means that the system has infinite solutions. So let's look at an example of that. Y equals 2x plus 4. It's in slope-intercept form. I go up to 4, and a slope of 2 over 1, or negative 2 over negative 1, and I draw that line. And then 1/2 y minus x equals 2, so I need to get that in slope-intercept form, so I add x to both sides, so I get x plus 2. To get rid of this 1/2, I multiply everything by 2, so that I get y equals 2x plus 4. I can recognize it's right here, the same line, so I'm going to go up to 4 and plot the same points, and so I say that there are infinite solutions. All right, now method 2, we can also use what we call substitution. Okay, and how? I'm going to substitute the value of x or y into the other equation. Okay, so for example, if I have y equals x plus 2 and also y equals 5, I'm going to take this value for y and I'm going to plug it up in here for y. So I'm going to say 5 equals x plus 2 minus 2 minus 2, 3 equals x. So now I have the value of x. I already know the value of y, so I say that my solution is, if x is 3, y is 5, and that is my solution.